How many here are developers? Okay, it's a pretty good turnout. We weren't really sure what was going to come, so we thought we were going to talk about StarkNet, and then we saw that 110 people signed up, and I know that 110 developers are not coming, so then we pivoted the conversation a little bit to make it a little bit more kind of accessible, but it's still going to be a technical one, right? The format is going to be a panel across all of the slides, because otherwise it gets really fucking boring. And if you guys have any questions, comments, just jump in, as long as it doesn't sound like you're correcting me. I'm okay with that. Because it's not an easy subject. So we're starting off with basics, like what is StarkNet? What is it supposed to help? And in order to understand that, we just need to make sure that some of the basics in terms of what zero-knowledge proofs are, which are not so fucking basic, and also how blockchains actually work so that we kind of get that full thread, right? And then we'll talk about application and a few little interesting pieces. Okay, so how many people here what a zero-knowledge proof is? Okay, don't correct me. So the basic, for those that don't know, the basic view of what a zero-knowledge proof is it's a way for you to verify that you actually know something without showing what it is that you know. It's kind of that simple, but it's actually pretty deep. It's at the heart of what the ZK part of the rollup actually is. So, again, for those that haven't gone through what a ZK proof actually is, this is a really, really good intuitive example. So we have two people, and I think that the standard names are Peggy and Victor, where Victor wants to know that Peggy has an answer, but Peggy doesn't want to share what that answer is. Right? So how does Peggy prove to Victor that she knows what she's talking about? So both of them enter into the cave. And then Victor tells Peggy to, and there's, you see that there's a little black kind of wall in the middle of the cave. Yeah, you can't really see here, but yeah, anyway. This one right there, right? So if Peggy knows the answer, then Peggy can put in the code, and that opens up the door, and that's kind of the proof. So the idea here is that both of them enter into the cave, and Peggy goes in, one of the sides. And Victor then says, well, I want you to come out through side A. And the only way that she could actually do that if she enters through B is by knowing the code. And in that way, she proves that she has the answer without actually saying what the answer is. But you need to do that a number of times, because there is a probability in this thing. So if she does it right the first time, then that was a 50-50 chance. If she does it right the second time, then the probability is lower that she actually got it right by fluke. And then you go continue, until you've done it X number of times. And yeah, people are quite comfortable knowing that she knows the answer. Does that sound right? Yeah? Okay, cool. Yeah, just go.
I took control of my
Okay.
I was enjoying watching you.
I think, Zoo, this was your slide, right? Okay, so I put this one here just because it's kind of a really pivotal part of the way that ZK proofs are typically used, and it also has a part that is that talks about compression, which again is really, really important in the ZK rollup. So let's say that we want to whitelist a set of addresses, right? And these down here, these are the addresses. Now, the way that, for example, Chainalysis do it with the OFAC list is that they actually have a map that they fill in with addresses every time something happens in that list. That's really expensive, and it doesn't work all the time, especially if it's a really, really big list. So what you can do instead is use some really clever maths and assume that all of these are your addresses. You want to prove that this address is actually in the list without the list being stored in the contract. So what is stored is actually the root up there. And all you need to do in the maths is basically say, well, I can prove that I am this person as long as I have that, as long as I know the blue hashes. Okay? So it's basically compression at a pretty high level in terms of being able to represent a very, very big list in the contract as only that root. Now, if we jump slide. Now, that tech is what we see in Tornado Cache. And I'm talking about Tornado Cache here simply because, again, it kind of goes forward into explaining how that ZK rollup works. So we have a bunch of criminals, and they want to wash some money, and they want to send that to a bunch of baddies, right? Obviously, that's the only use case. So how does it work? How many people have actually not used Tornado Cache here? Yeah, okay, before it was illegal. Okay, a few people, good. Okay, so for those that haven't, openly, what happens is that you basically choose to deploy a set of, or you choose to wash, you have a choice for the amount of tokens that you want to wash. And once you've chosen, let's say, 1 ETH, that 1 ETH goes into a pool. And then a bunch of people put that 1 ETH into the same pool. And when they do so, what they do is that they get a little note, and that note has used zero knowledge proof technology so that the hash of that note is actually sent into the contract. And a hash of something is basically just a shortened representation of that something, where there is a very high likelihood that there's only that something that can actually create that hash. Does that kind of make sense? I'm seeing most nodding. I'll go for that. No, not yet. Go back. Go back? Yeah. Okay. So, this way. So the people online can see you as well. Okay, cool. Yeah, I'm trying to, I can't choose now. Okay. So here we see that we have the note. That note is kind of like a private key. And what happens is that the user, when they deposit the money together with a hash. And when they're going to take out that money, what they use to take the money out is not the actual note, because if they show the note, then somebody can actually see, well, that criminal A1 is actually baddie 2, because you're sharing the same information. The beautiful thing with zero knowledge proofs is that this technology can actually let the contract know that that you are you without actually showing that you are you, right? Which is quite cool. Now flip next slide. Yeah, go ahead.
Yeah. No, so the reason we showed that Merkle tree before, so if you mind just going back to that. So what this Merkle trees actually solve for is proving set inclusion. Just proving, hey, I was actually in that washing machine, right? That's what we were trying to prove with the Merkle tree, which is why we showed it to you. So then with zero knowledge proofs, you can say, hey, I was included in that Merkle tree without actually showing, the data you have to prove to include it. So using zero knowledge proofs as well as Merkle trees, you can say, hey, I was in that washing machine, hence I am entitled to a portion of the contents of that without revealing any information. So that's actually where that fits in.
Can I ask the dumb question?
Yeah, go for it.
So if you put, let's say you put 1 ETH into the washing machine and it goes through those processes, does the same ETH come out to the baddie at the other end? Or is it a different one? Because this goes to the legal aspects of the commingling, or this perhaps a misnomer that there is commingled and tainted funds.
Right. So this comes down to the problem of fungibility, right? Say, for example, you put $10 into the bank and then you take $10 out. Is that going to be the same $10 note you put in? Very unlikely. So, but it's also like, how could you tell the difference, right? So there's no really way to uniquely identify a portion of that. So that's the reason, like, you couldn't say it's the same one. It's just the amount that you get back, that's right.
Or is it a question of just probabilities and the chance that it is obscured, that there's a chance that it's obscured, that nobody can trace it back to you?
So So are you asking, is there a chance that the output that you get when you're claiming some, money from Tornado Cash, what's the chance that it's the same piece that you put in? Well, I guess
I know that doesn't work from a token perspective, but from a legal analysis perspective, if you're looking at if there is one bad apple in that pool, have you tainted all of the others because there's a chance that they may also now be the illicit fund, so to speak?
Yeah, so I guess that's where zero-knowledge proofs are also very useful. For example, you could technically create a proof that says, hey, I wasn't the person who, interacted with this bad protocol. Say, for example, there's a major DeFi hack, and, there's, it's a breach in the smart contracts, and then someone takes millions of dollars. You could create a proof that, hey, this address that I used wasn't the one that did this bad act. So there are ways you could, I guess, prove that you weren't the bad one, but yes, there is some degree, some tainting of the pool.
And I think that the thing is that if you're dealing with cash, you can actually say that this note, which is uniquely identified because it has a serial number, when it moves between different people, it is that you can actually track that note. Yeah. While as by definition and fungibility, all of them are congruent, they're all equivalent.
But sorry, we might be going off topic here, but even money is notionally considered to be fungible, but it's actually not. If I was really particular, I might like to say that I want to be paid $100,000, but only in banknotes that have a serial number that end in an 8. Yeah. So it's a subjective, but that's kind of splitting hairs. Anyway.
Lawyers.
That's valid.
So if the point with this slide is just to show that, this is for people's curiosity, there are libraries out there that allow you to actually define so-called circuits that enable you to create zero-knowledge proofs in a more general sense. And these are the two libraries that actually Tornado Cash used. Now, let's park the concepts here for a second in terms of what ZKPs are. And let's just talk about blockchains, because bear in mind that in order to talk about zero-knowledge rollups, we need to talk about both what ZKPs are and also what rollups are. And to understand what rollups are, we need to understand what problem they're actually solving, and that's what we're going to try to explain really, really quickly. So this is my really shitty explanation of what a blockchain is. So the point that I want to highlight here is we have external accounts. Those external accounts send transactions over to the blockchain, which is set up of a set of validators, and I'm talking about ETH 2.0 here, by the way, where ETH 1, the validators are not validators, they're actually miners. So I'm going to explain one thing there that is quite relevant. But as the transactions get processed by the validators, which basically means that every transaction, or I don't know if it's every transaction gets recomputed by every validator or by a majority of validators. But anyway, it's a lot of recomputation that happens to validate the transaction. Once that happens and you assume that the transaction is correct, then it goes into the block. So the two things that rollups are trying to solve is gas costs and ability for throughput. So when we're talking about throughput, it's about the amount of transactions that are going into the chain. And the cost here is dependent on the amount of demand that the transactions need, or rather the accounts need, to be able to start filling up those blocks. Now, I know that there are a lot of people that think that ETH 2.0 is going to be cheaper than ETH 1, and the reason why that is not going to be the case, nor that it's able to have more throughput, is because the only thing that you're changing here architecturally is that the validators are validators that stake instead of actually mine. But the amount of processing power to validate the transactions is still going to be the same. And the size that these transactions take up when they're filling the blocks in measure of gas, it's still the same. So again, there's not going to be a change there. So we still need L2s. Now, next slide. Okay, so now here's where StarkNet comes in. And what StarkNet does is that it sets as a middle layer here, where the external accounts send all of the transactions into StarkNet, and StarkNet does its magic. And it truly is magical. Because what happens is that every single transaction, when it gets submitted, it actually gets validated upon submission because of the zero-knowledge proof. You're basically telling the network, here's what I'm doing, and this is the reason why it's correct. So you just need to validate it once, and it's done. So the computing power to actually validate the transaction goes down tremendously. On top of that, once StarkNet has processed those transactions and submits it into the blockchain, apart from the blockchain needing to do much less work to validate, they're also compressing many transactions into many transactions at the L2 level to one transaction at the L1 level. So when that gets stored into the blockchain, then you're basically taking up much more space per transaction, and you're basically sharing the cost. So the more people actually transact with it, the more people you have to split the cost with. Therefore, per transaction, it's much cheaper.
So taking up less space.
Yes.
Yeah.
Am I missing anything here?
No, you just said taking up more space.
Yeah, okay.
Yeah, no, I think Arturo covered it pretty well, but I think just to reiterate, there's two levels, I guess, of savings that are made here. One is at the computational level. So because all of the computation is done on the StarkNet L2, what happens is that the validators on L1 Ethereum don't have to do that same computation. There is another interesting layer of cost savings, which I don't think you mentioned, but that's also state differences. Basically, what happens is, because on StarkNet L2, you're doing lots of transactions. Let's say, for example, a Uniswap exists on StarkNet, right? There may be lots of transactions happening and lots of state changing, right? On Ethereum, every single state change would result in, some sort of update, and that has a cost associated with it. But on StarkNet, what you can do is you can abstract that away to a stage where all you need is the beginning state and the end state, and that's the only update that's done. And that also realizes a lot of cost savings for end users using StarkNet.
One point that is quite interesting here is that going back to the whole Tornado Cash thing and the censorship of the blockchain, there are conversations about censoring at base layer, right? What that means is that you're changing the software that runs the validators so that they don't process transactions, or they don't validate transactions that are coming from specific addresses. Now, question is, what happens when you don't need to validate that transaction? Because it's already validated by the ZK proof. So there's some really interesting consequences of actually.
Does that shift the burden or the onus of that process to the StarkNet?
Awesome. Yeah, that's an interesting question, because I'm sure, I think what we're referring to here is node level censorship of particular addresses, right? And this is what happened with, I guess the US government's sanctions and people actually doing that at the node level. So I guess to some degree, maybe the government could say to StarkWare, hey, if you don't censor these particular addresses because they're malicious or were involved in this hack, we'll get you. So maybe there is some risk to being an entity like StarkWare that could be called out. But I guess to some degree it does move the onus onto StarkWare solution. That's very much dependent because of the centralization of the sequencer right now as well. So StarkWare, that StarkNet L2 box right now is centralized, the sequencer. There are plans to decentralize this. So maybe that would introduce a new spanner in the mix.
I think the only spanner that would introduce is how regulators would seek to regulate.
Exactly, yeah.
Which probably comes into this whole idea of the importance of censorship, or the role of censorship. And I know it's got a lot of public attention lately, but I think it's really important to understand the role of law and regulation. As much as a lot of people in the community don't like the concept of being regulated and having laws apply, I think the thing that we need to bear in mind is the overarching purpose of law is to regulate how we as humans interact and live together. If we were really good at doing that for the benefit of everybody, we wouldn't need to rely as heavily on the laws as we do. And I think as much as some of these protocols have been developed and gone out and been unleashed on the world and done some really great things, and will continue to do so, I think we have to recognise that to the extent that there are harms that could eventuate, because there are human users at the end of these processes and these systems, that's where the regulators are going to focus. And it's always going to be a messy process of either the laws catching up or the technology catching up, and it'll swing. So yeah, I don't know how much you want to go into that, but it's an important point to recognise that there are overarching principles of harm. If we look through the technology, so this is a really great example, is if society decides that there is merit in censorship, it will be a question of which part of the technology ends up being the best place to carry out that function.
Yeah, I think that so we wanted to have this conversation because as developers now, you really need to be careful with what you're actually deploying on chain. Because if you don't have the right tools, if you don't deploy things the right way, potentially if you don't deploy contracts that you're able to censor, you can get into a lot of trouble, which effectively is what happened with Tornado Cash, right, in one way or another, right? It's still up to debate. But question is, why StarkNet? Right, what's the real power with StarkNet? And the power here is that you're able to have a lot more compute-intensive workflows. And we're going to get into that both on the DeFi side and on the GameFi side. But in general, by deploying more workflows on-chain, then you need to be even more careful that the workflows that you are deploying on-chain are actually okay from a legal standpoint. Because once they're there, then they're there. So, yeah, I think that we can jump on to next slide, Mark. All good. Okay, so here's an example of one of the protocols that we're building with StarkNet, and a few of the things that would be really difficult to do unless we had the high compute ability that StarkNet offers. Next one. There we go. So. What TradeFlows is a way for people to describe deals on chain and to effectively manage liquidity. So it's a few steps, basically 5 steps, where first the service provider and a buyer decide that they want to do a trade. Then once that trade is decided, the service provider mints an NFT and the deal is represented as that actual NFT, and the terms and so forth are in there. The NFT is owned by the service provider. Now the buyer then agrees to the trade on chain by calling and agreeing extensions to the ERC 721 contract. And once they do that, they start a payment flow into the NFT, into the trade, through an escrow token, an ERC 1155, and then an ERC 1120. Now, that's basically just a standard deal, and it has a lot of benefits, right? It gives both the service provider and the buyer a lot of transparency. Mostly, the service provider has the transparency of knowing that funds are actually available and that they're escrowed, so they're earmarked. But the buyer isn't actually paying in advance because they still control the money. It's still an escrow account that is in their control. And they're able to withdraw money from that escrow account whenever they want, but the service provider can then see that and act accordingly. Now, this on its own is very easy to do on any blockchain. But the consequences are actually quite interesting once you start looking at the entire supply chain. So first of all, before we jump onto the next slide, remember in this case that we're defining risk as the notional agreed versus what is actually in the escrow account. So for example, I could say that I'm going to pay you $100 over the entire deal, but I'm only collateralizing with 10. Therefore, there is $90 that is extra risk there. Now, if we jump on to the next slide, keep that in mind, and then just extrapolate that picture that we saw before across, let's say, one industry where one service provider or one buyer actually becomes a service provider for another part of the blockchain, of the supply chain. And they're all interconnected. So this is basically just showing the entire supply chain together with multiple industries. And in reality, the economy is actually all, it's a lattice in that way. So next slide. Okay. Oh, I can flippy. Okay, cool. So what we're doing is that with that risk view, and also I forgot to mention that there is a collaboration view, a way to rate each other from a collaborative point of view within each transaction. What it allows you to do is actually create a risk view of the entire lattice or the entire economy, together with a collaboration view of the entire economy, which then also gives you an ability to understand where you actually need to deploy liquidity, right? But this is at an economy level. Now, the consequence of that is that you can actually create liquidity pools where you have providers that are willing to fund or provide liquidity not only to a specific node or a company in Web 2 terms, but to an entire part of the supply chain. Let's call it a trace of the market. And in so doing, doing it with a little bit more security, because the reality is that you decide to fund a specific company, but if that company is connected to other shitty companies, then that company is going to go down. And you don't have the ability to actually see that. This is a model for you to be able to have that level of control, but on chain. Now, to be able to do those calculations, you need to be able to do the aggregation calculation of the risks and also understand how much you're actually deploying on chain when you're transacting, right? And that computation would cost a shitload if you do it on mainnet, but it's completely possible if you do it on StarkNet. So, yeah, I think that any thoughts, questions here? Because the next part is about games.
The fun part. Okay, so hey, I'm Rez from ImmutableX. So I'm going to be talking a bit about how StarkNet enables games. And the reason I'm going to talk about games is because games actually have one of the biggest communities in StarkNet right now. They're also generally speaking, they're also one of the pioneers to adopt new technology because of limited barriers in the legal space, as well as just a mind frame of innovation in general. And ImmutableX, we're taking the strategy of actually, looking at games and seeing how we can best help them, in this, I guess, new Web3 world. And also, shameless plug, follow me on Twitter, OXZoras. Next slide, please. Oh, yeah. The clicker. Yep, so how are we actually seeing games being enabled on StarkNet, and what's the actual innovations that StarkNet is providing to help make games successful? So who here has heard of account abstraction? Show of hands. Okay, a few of you, all right. Not too bad, I still have something to talk about. So before we can talk about account abstraction, we need to talk about authorization and how authorization occurs on Ethereum L1 currently. Right now, whenever you want to claim or authorize a particular transaction on Ethereum L1, you generally do it by signing a particular payload with your private key. It uses public-private key cryptography. Pretty simple, but its simplicity is also its limitation. Because of this, we often see the UX question raised quite often. Right now, you might sign transactions through your MetaMask wallet, for example. What does that involve? Every time you want to authorize a particular action, a MetaMask pop-up comes up, you have to sign that transaction, and that's not a great UX. Imagine that for games now. Imagine you're playing RuneScape and you're clicking a tree and you're hoping to get some wood, and then suddenly a MetaMask pop-up transaction comes up, accept wood. That's not an experience that people want to have. And this doesn't just apply to games. Games might be the pioneers here, but this applies to all aspects. So that's where the account abstraction actually comes in. We can actually codify the authorization logic and go beyond simple public-private key cryptography. And this means we can explore novel solutions for the UX problem when it comes to wallets. So, for example, something I saw recently in the StarkNet ecosystem is people actually signing transactions with Face ID, because mobiles right now, they have a secure enclave with private keys which you can use to actually sign. And we can actually codify that logic in a Cairo smart contract for StarkNet and say, hey, that's what I want to do. What if you're playing a game? You can actually write down in your account contract that, hey, I don't want to sign transactions right now. I want to keep my authorization persistent for a period of time, so I don't have to keep doing interactions. And this is allowing for novel UX, which games need and other applications definitely need. And the UX problem always comes up, and this is the solutions we're starting to finally adopt. So, I want you to imagine a world you're playing a mobile game. You can sign with your Face ID, and then once you're signed in, you have a session key that's persisted by your account contract, and you can keep playing without having to do more clicks. And then let's say you actually lose your phone, and you no longer have that private key. We can actually implement social recovery methods in that actual account contract, so you can recover your account. And this means, a Web 2 experience which we're familiar with is forgot password or lost password, but now we can actually do interesting things here and, have recovery mechanisms. Sorry, did you want to say?
No, he's offering me water.
Oh, yeah, go for it.
Thank you.
And also another thing we see at the enterprise level, it's very common that if you have private keys, you generally want to rotate them after a period of time. If you're an enterprise and you have a private key with assets, you can't really rotate keys if your identity is defined by the key that you hold. So this is the interesting things we're seeing with account abstraction. One of the things that StarkNet actually natively supports. So it's a great area of innovation. Question, go for it.
Yeah. I'm sure there are absolutely no legal repercussions of that identity aspect, right?
No. Identity is a really, really tricky one, and it's a really important one because it dovetails with privacy the whole way through. And I think this is where it's a really great example of looking at these new solutions that are coming to solve for problems. And I hear exactly what you're saying in terms of that the gaming is really driving innovation in this space. And I love the fact that some of these innovations will form the basis of our future rails of our digital economies, you know, that things that were invented in video games and tested by a whole bunch of teenagers. So well done, you guys. You're absolutely right. There are all sorts of legal implications along that way, along the journey there of the user experience and those different components of technology. And again, we need to step back and look at, well, what's the purpose of the laws that we have? So, for example, GDPR, the control of, you know, the obligations that are imposed on various points of that process. Who is a controller for the purposes of GDPR? Who has the obligations to manage any of that personal information? And how does it flow through? And as we add these layers of technology, it doesn't change the underlying purpose of those laws, but it creates new opportunities for us to work smarter in the way that we manage and control our digital identity as we increasingly have these digital touch points. So,
yeah. And on top of that, Web3 games are basically trading systems of currencies.
Sorry?
Of currencies.
Of
They're
currencies.
they're in-game currencies, but they're still...
They're utility tokens, aren't they?
Wink, wink.
For now.
Yeah, no, that's an interesting point because, you know, generally in Ethereum L1, your identity is represented by the address derived from your public key, which is, you know, related to your private key. So now your on-chain identity, if it is in an account abstraction world, that account contract could be a multi-sig owned by 20 people. So how does accountability work in that?
And I think there's still a lot of, there's debate around, you know, how does GDPR apply to blockchain and to the different aspects of that. So is a validator a controller for the purposes of GDPR? And it's also, I think, really important to look at the fact that these games and systems are used and interacted with by humans across multiple jurisdictions. So you've got, in the case of GDPR, as that example, it's kind of the high standard and it applies across multiple jurisdictions. But as we touch on the user experience in those jurisdictions where the user is, we can be triggering other laws along the way. So we've also got to think about it from that perspective.
Right, interesting. So I guess to summarize some of the discussions that we've had now, so Arturo mentioned about, you know, on-chain computation. That was really expensive before, and we've talked about how we can reduce costs in that aspect. So, you know, on-chain games were too expensive before, right? Complex computation, too expensive. With NFTs as well, you know, a lot of games may choose not to have on-chain logic, but they still might want to have digital assets with true ownership in our composable Web3 world. And even then, minting and trading is expensive. With ZKP technology, it gets a lot cheaper and a lot more accessible. Then we talked about account abstraction and the wallet UX. And there, of course, we are seeing the improvements with account abstraction. So these are just a summary of a handful of games which are actually building in the StarkNet ecosystem. Most of the companies that I could say are building are actually games, and they're actually quite interesting, ranging from things like strategy to building. So it's a snapshot to say people are building. So how does Immutable actually fit in as well? So we're really bullish on games needing digital assets and giving true ownership to people. So I'm not sure about you guys, but I used to play RuneScape for years as a kid, and I actually have nothing to show for it now besides maybe like a forgotten, actually no, I think I recovered my account, but I have assets which I spent hundreds of hours putting in, and I have nothing to show for it. Even Path of Exile, which is in the bottom left. Any Path of Exile players here? No? Okay. But even that game, right? I spent probably hundreds or thousands of dollars on cosmetic skins, and she's embarrassing, but yeah, like I have nothing to show for that. Even if, you know, I wanted to, you know, trade it or do anything with it in game, like there's just nothing I can do with it. And how Immutable fits in with the StarkWare StarkNet solution, we make it really easy and accessible for games to integrate trading for digital assets with off-the-shelf solutions through simple APIs. So you can build a marketplace in your game without any Web3 knowledge and start to give true digital ownership to people. And that's like straight off the shelf. All of these marketplaces, these were probably coded in-game, in custom logic, and this is something that each game had to rinse and repeat. Games have digital economies. They do have, like a lot of games have economies, and we believe that's the case, and we're trying to facilitate and support that. So that's a little shill there. So how are we actually doing it? Introduce Cairo. Who's actually heard of Cairo here? Okay, nice. So Cairo is a smart contract language which we actually write with to actually write smart contracts on StarkNet. If you're familiar with smart contracts on Solidity, the general paradigm is not too dissimilar, but there are obviously a few key differences. And the reason there are differences is because we want to support a Stark-friendly CPU architecture. The EVM architecture is not Stark-friendly. And what that means is, it's very difficult to support Stark proofs, and if we did, it would be really expensive. Moving in, so anyone ever did Solidity dev here? Solidity devs, okay, a few of us. So this is just a quick side-by-side of what Cairo looks like on the left versus Solidity on the right. This is taken from the OpenZeppelin ERC 721, where we're doing a simple transfer. And we can see, of course, that in the Cairo we have function arguments similar to any programming language, for example, from, to, token ID, and that's a very similar thing we have in the Solidity there. I won't dive too much into the code because we did only have about 5 Solidity devs here. But the general gist is we can represent the same things that people do in Solidity. We can do that in Cairo as well.
One thing to add here is that looking at that code, it looks a bit like a clusterfuck, and it is, in comparison to Solidity. But now think of, I don't know if you've looked at Circom. The way that you create ZK snarks, which are slightly different to Starks, those, when you're actually coding and creating a zero-knowledge proof circuit, you're actually creating polynomial representation of the actual problem, which makes the description of the problem much more difficult. What these guys have managed to do is actually have a Turing-complete language that you can actually read, and you don't need to be a math whiz to use in order to create almost any zero-knowledge proof, which is astounding. Like, that's really, really next level.
Cool. So now that we've seen, I guess, Cairo and Solidity here, let's move on. So why learn Cairo? This is a conversation that often comes up as well now that we've seen a few ZK EVMs as well. So have some of you guys heard of ZK EVMs? Show of hands, I guess. Yeah, I see a few nods, nice. So the reasons here are outlined. The core infrastructure is not well suited, the EVM architecture is not well suited for ZK rollups. When we do try and build circuits using an EVM architecture, the proofs are much larger and they're much harder, they're much more expensive as well. And those costs are going to carry on to end users. I like to give the example of OpenSea. OpenSea had a settlement protocol which was Wyvern about a few months ago, and then they built their own protocol in Solidity, but they did it in assembly. So Solidity assembly is very low-level code which most people don't write. But the reason they did that is because they knew for the end user, the costs would be lower. And the focus was on the end user, right? It wasn't about the development experience. The focus was the end user. And this is always the experience that Web 2 companies take. It's always about customer first. So why are we focusing on a language which is going to cost more to end users when we should be focusing on the benefit it has to the end users itself? So, the example I give is like, you might watch Netflix, right? And obviously they're known for being an engineering powerhouse, right? But when did you ask yourself what tech stack Netflix uses? Unless any of you work there, but hi. But yeah, that's the point here, right? We try and do the best thing, the thing that's going to have the best outcome for the end customer. And if that means writing in a language that's going to have smaller proofs and better costs, that's what companies are going to want to do. And that's why we're focused on Cairo. Yeah, I think that's from me. Yeah, jump in.
Just gonna test this. Oh yeah, that works. Okay, yeah, Juan, also known as A5 Farmer. That's my plug right there. So I went to ETHCC and I'm gonna get down, just get over the less interesting stuff first, which is Cairo-centric news, I guess you can say. So as you can see in this slide, which one do you think is harder to develop on? Obviously Cairo, right? Like, but good news is it will change in about 6 months' time. Cairo 1.0, it's gonna introduce a lot of life quality improvements. Let me just pull up my notes so I don't miss any points. Reminders. Yeah. The other thing about developing in Cairo is it's a lot slower than doing Solidity development. The tooling is not up to scratch as Solidity, but apparently Cairo 1.0 is gonna have a Rust compiler, which is a lot faster. It will have higher level, I guess, variables. If you've developed on Cairo, I think strings are actually not natively supported. You have to convert a decimal number to strings. But again, that will change in 6 months' time, apparently, with Cairo 1.0. And well, if it's gonna change a lot in 6 months' time, what's the point of learning Cairo? Cairo and Cairo code is going to be portable easily into 1.0 code. So don't worry, your code base is not gonna get scratched. Yeah. That first QR code is actually a talk by Sahar Papini, which is the creator of Cairo, I think co-creator of Cairo. So he will explain if you want to know more about Cairo 1.0 and what it entails. That's the YouTube video to check out. And then the next point is Eli Ben Sasson, which is one of the, I think it's the CEO. He talked about the token release in September. And yeah, with StarkNet, devs is like the first class citizen, you know, and if you have a Cairo app running on StarkNet and you have a lot of users, the amount of Stark tokens you will get scales up based on your traffic. So if you have a successful app, then you will get a lot of StarkNet tokens. But the other thing is that's quite interesting for me was what happens to the people who build the libraries, right? They don't actually own the apps. They thought about this. So let's just say you did StarkNet.js, which is like a massive, it's like a must-have for like anyone who uses StarkNet now, right? So good libraries owners will own a lot of StarkNet tokens too, which is, I think, something that's super cool. I don't think anyone has done it like this. And the other cool thing that I noticed is their community building efforts are starting to get decentralized. So like, it's not just all StarkWare starting their events. So as an example is StarkNet.cc. It's their first community, and it's not even organized by StarkNet. It's by this company called Only Dust. Check out their media, twitter.com StarkNet.cc/media. It's quite a good event. And then a few photos from ETHCC. So that's the less interesting stuff. Let's go to the pictures. Yeah. So yeah, obviously there's always a Vitalik and an Ethereum-based conference, right? Yeah, not much to say there really. Oh yeah, I just noticed that. How much are those socks? 30 grand. It was a lot more back in the days, right? Yeah. All right, next slide. And a lot of merch. If you go to one of these conferences in the Northern Hemisphere, like, yeah, you get whatever your flavor is, you will get your own merch. Like, it's crazy. Yeah, and you obviously can just come to any booth and pick some up. Yeah, don't have to do any shopping for a while, you know. Next thing is, oh yeah, and then I met Eli Ben Sasson in one of the rooms. It was pretty cool, actually. Now, you're wondering, how would I get one of these mean t-shirts, right? We got something for you after this. You're going to do some questions, I guess.
Yeah, before we get into that, I thought that let's open up to just conversation, because I see that there are a few StarkNet developers here, others that are interested, and let's dive into it. And you don't always get to talk to somebody like this and actually ask proper questions, so please do.
Hey, actually, I have a question for Raz. Have you heard about any SDK support for Unity or Unreal Engine for game developers? So that's the first question. Second question, if I already have a Cairo contract deployed on StarkNet, and I want to migrate to immutable, do I need to scratch my contract and start using immutable RESTful API, or how that part work? Yeah. Thank you.
So 2 levels to that question. So one was the SDK part. So my understanding is that our team is working on the SDKs relevant for games, which involves things like Unity. And the second part was your smart contracts on Cairo. Do you have to throw that away and migrate to immutable? No, we're actually working on building up our system with StarkNet support natively. So what that means is if you have, say, for example, ERC 721s on StarkNet, and they follow the standard that's on StarkNet, then we will support that in our order book and trading system. Questions? Oh, yeah. Here you go.
So I don't know which question this is directed to, so I'm just going to ask the question. So I think it was 1 or 2 months ago, DOIDX announced that they're moving to an L2 away from StarkWare-based technology. I'm not super aware of the ecosystem, so can you give a bit more context onto maybe some of the reasons why they decided to do this?
Anyone?
So this is pure hearsay, but what I've been reading, and I think that it makes sense for them, is that they wanted to have, obviously they want to have more control over the stack, but specifically the reason why they needed to have that control is because they needed to define the way in which fees were charged. So they wanted to be able to charge fees on the basis of size of trade instead of actual transactional volume. Let's put it that way. Now that being said, not everybody can actually do that, right? Because you need to have a community that's big enough to be willing to act as miners or validators or whatever that blockchain effectively has. And I think that they were going for, what's the name of that blockchain standard? Cosmos, yeah, correct. But again, like functionally, you can create something that is up to standard, but you need to get people to actually use it and deploy liquidity into it. So yeah, it doesn't make sense for everyone, to be honest.
I can add a note to that. Yeah, so obviously DOIDX, they were on the StarkX solution, which I would say is very different to StarkNet. StarkX is not a general purpose application. It's a fixed use case, right? So we have very limited, I guess, malleability on how we can change that. So for example, right now, if you want to change that fixed application, it requires interaction with StarkWare to say, hey, we want to change the DOIDX StarkX application to support something else. So it doesn't support very easy. If you have new use cases or new requirements, it's very difficult to support that. But it's StarkX, not StarkNet. They're very different.
Say your name. I'm Sagan. I don't know who the question's for, but sounds like a lot of great benefits. Definitely sort of more throughput, less cost, efficient to be able to do a lot of different things for cheaper and volume-wise and for gaming, etc. Are there any sort of risks associated with application of this, or are we, is it effectively pretty much like transacting on L1? I'm just curious, or are the risks so small that it's kind of worth the benefit of the tech and utilizing that?
Who wants to go first?
Yeah, I can start if you want. But, so there are risks, right? I think one of the ones that you can start off is talking about is finality. On L2, you have to decide for your application what does finality mean, right? Full finality would mean that you wait until your proof is generated, and then it's submitted to L1, and then accepted on L1, and then you could say, hey, that's finality, right? That takes a while, and it's not going to be applicable for many applications. Then there's another level of finality. Maybe you're happy saying, hey, I just want it to be submitted to the sequencer on L2. Once they've acknowledged it, that's finality for me. So there are some gaps there around finality, which I think is one of the call-outs off the top of my head, but I'll pass it on to the others.
Yeah, I mean, at this stage, it's not on mainnet, like properly. So I think that's one of the big things if you're developing, right? Honestly, I don't know exactly what alternative I would choose, to be fair. So we kind of put all our eggs in one basket when it came to developing that protocol. But it's an interesting question what finality actually is. I don't know, it'd be really cool to have a short one with regards to describing the differences in finality between the different L2s. If actually, even if there are other people within the, even if there are other people, and I'm looking at Cam right there. Come on. Cam is our mastermind research guy. No, but so finality. When you're trying to educate yourself on blockchain, or at least me, I tend to read on various articles, and not every article is written the same way, and there's a lot of incorrectness in articles. For example, I was reading that optimism had instant finality, which it obviously does not have. But if you're starting to read into it, then you just take it as a given because it's written. It has to be true, right? Now, if you're going into optimism, I believe that, and you define finality in a transaction as your ability to actually extract value from the chain, right? Then I believe that's what is it, about a week or 2 weeks time that you have to wait until that's actually happened, right? Now, if you're writing a DeFi application, then that's, at least from my point of view, a no-go. You can't expect people to wait a week for a withdrawal, right? I believe that there are other ZK rollups that have faster finality. Well, they would obviously have faster finality than that, but I believe that StarkNet is the one that has the fastest finality in architecture, right?
So I guess finality, it's really up to StarkWare to decide how often they want to post to L1. The more frequent they post, the more expensive it's going to be because obviously there's L1 costs associated with it. But they also say they are exploring solutions such as checkpointing, which is another area where they're elaborating where you might be able to increase that finality guarantee. And then other solutions include, for example, running your own sequencer on L2 so that you have the source of truth as well. This is common, for example, in Ethereum, where if you want to know that something is true, then the best solution is to have your own node. This will likely be another potential solution down the line towards decentralization of StarkNet. But yeah, that's my sense.
Got a question here from Pratik. Say your name and where you work.
Hey, hello. My name's Pratik. I work at DigitalX as an investment analyst. My question is, what are the compute requirements to run a StarkNet validator or server? Because it's not going to be run on Raspberry Pi, from what I understand. And if the compute requirements are, you need a server farm, or you need to run it at AWS or Google, how is it really different from incumbent chains like Solana stuff, which have heavy hardware requirements as well? And what is the path to decentralization from there? Because it might end up being that you will still have 50, 100 validators, and because it's so expensive to run a validator, it's not really decentralized. And then how are you really different to an incumbent blockchain with Rust, developer tools, and so on? Maybe a hairy question, but...
We love really big, hairy questions. And by the way, audience upstairs, if you do want to ask a question, just put your hand up, or maybe just come down to the top of the stairs. We'll meet you halfway. So, and I forgot what your question was, but you guys remember? Yeah.
Okay, yeah, big question, of course. So I'll try and answer that as best as I can. So I guess your question is what sort of hardware requirements are there to run your own node, and if it's actually as intensive as something like a Solana node, because obviously that has some pretty steep minimum requirements. So one, it means you have to define what is running a node. So right now, running a node on StarkWare means that you essentially have a data replica. So it's essentially a read-only replica of the state. In terms of submissions, the source of truth for submissions is the StarkNet node. If you want to, in the future, to when decentralization is, one of the key aspects, then we have to start thinking about who is actually running the prover. The prover is the biggest source of computation, which is the requirements. So the reality is you don't need many people running the prover because you only need a few people for high availability, you only need like a few people to run the prover, and you don't need everyone else to run it. So in terms of requirements, it won't be significant. That's my take on it right now, but in terms, yep, go for it.
You've also got the point of recursion as well, the benefit of recursive proving and the efficiencies you get from that.
Yeah, again, that's, I think, a more advanced topic, but there are solutions being explored, for example, L3s and recursive proving that, make it even easier, but yeah. Yeah.
What was that?
I was just saying that doesn't recursion require a lot of memory, from my understanding.
Does it?
Well, I guess that's a traditional Web 2 application, but we can talk more about this afterwards, I think. Yeah.
This is the first of hopefully many of these kinds of things, and we'll probably do them mainly out of Sydney, just given Immutable is here and given that Atur and I are based out of here. But if you know AusDeFi, we travel around, so if you scratch hard enough, we're probably going to do it in Melbourne and yeah, Nathan, yeah, I know. Thanks for coming up, by the way. Hands up if you come here from interstate. There's a few. It's good. No, thank you. Really appreciate you guys coming down and stuff. But this is the first of hopefully many of these, especially as stuff gets more mainstream. Does anyone else have yep, Aaron?
All right, so I'm going to just address the elephant in the room. So optimistic rollups, do you guys think they have a general future in the L2 space, considering that is like the big debate if who's going to succeed, ZK or optimistic rollups?
ZK or optimistic, crystal ball, Juan?
So I have a friend. He was deciding on a protocol, on what blockchain to use, right, for his thing. And after talking to a lot of people, please do your own research, by the way. Just a disclaimer. People say, they say optimistic rollups are a band-aid, and ZK rollup is the real fix. Because I think optimistic rollup is like a more centralized solution in terms of scaling, in my opinion. And you can also see with the ZK proofs, the more transactions that go into a particular L1 transaction back, the less the cost is per transaction, which means the more transaction you have, the cheaper it is. It's literally it's like a Benjamin Button kind of thing, which is quite interesting.
I don't know, would it be fair to say that an optimistic rollup is a bit of a YOLO rollup, right? You let things go until somebody actually proves that it's wrong, and you have a window of time for that proof, that error proof, to actually go through, right? Which is a completely different concept to the ZK part, which is kind of the opposite in terms of YOLOing. You're just proving before you even open the door, you're proving that you're correct.
No, you go.
Yeah, no, I think, I remember reading something about fraud proofs and how oftentimes many people weren't even doing fraud proof checking, which was interesting. But I think for me, one of the biggest, wins that ZK proofs have over optimistic is the fact that you can have off-chain data availability. And what this means is you can employ things like Validium. So what Validium means is you can separate your state from you can separate your state to and offload that to a DAC, which is a data availability committee or something like that, and have your state off-chain. And this significantly reduces on-chain costs. Now, of course, there are EIPs on L1 which could mitigate this as well. But I think that's one of the big wins as well that ZK Rollups has right now.
Yeah, actually, on the topic of abstraction, slightly off topic, but still linked to this, I was having a conversation with a really, really smart developer that was explaining the L2 and specifically how StarkNet was doing it. And they said something really cool, which was that what StarkNet does is that it abstracts the computational description of a blockchain and separates the validation from the actual computation. Something that in traditional L1s it's one and the same, right? You have the validator that actually runs the computation and also validates it. While as in the L2 and in the way that StarkNet does it, there's a separation, right? You have one that actually computes and then the other one that actually validates because it's done automatically. So it's not the same software in the same way as it was before.
We got a question from Ken. Do you want to come up here? No, okay, cool. Offer's there.
Hey Ben, this one's just for Reds. You mentioned before the difference between developing in Cairo compared to developing on a ZK EVM, and the speed differences are far better in Cairo, right? So do you have like an example or maybe context as to like what that difference is and how much it is? Maybe between like ZK EVM and like StarkNet, because it's universal, right?
Good question. Where do you work for? Like, what?
Yeah. So this is actually a tricky problem because one, the other ZK EVMs don't really have real production workloads, so we don't have any tangible numbers. Most you can do is kind of like guesstimate, and even then we don't know how the compute costs are translating on those ZK EVMs for the actual proof generation, because right now they're running the provers themselves, so we don't know what that's going to look like when it's actually forwarded onto the end user. So there are a lot of unknowns here. So even I've looked for those numbers, haven't got them yet, but I'll let you know when I do.
But there's a rationale as to why the ZK EVMs that we know of should be slower. And it's because they use the ZK snark technology versus the ZK Stark technology. ZK snarks, I think that they're actually quite similar, with the difference that snarks use elliptic curve cryptography, which is computationally much more expensive than Starks, which just uses hashes, which also has the consequence of making Starks post-quantum secure, as opposed to snarks that I believe are not. And also, I think that the proof size is different. So I think that the proof size of the Stark is smaller than the snark. So there are a few benefits there.
It's bigger.
Oh, the other way around.
Because of
yeah.
the EVM circuits.
So we can record it. We're trying to record it.
Yeah, no, the Stark proofs are bigger than snarks in general, but because if you're building on an EVM architecture which is not designed for ZK proof generation, simple things like even UINT 256 usage is going to blow out of proportion how many gates in your circuit or whatnot. So that's how the proofs are actually going to be affected.
The other thing is with ZK EVM, right? It's you still, I guess you get the benefit of like solidity tooling because it's going to be EVM. But the thing is, just think about like you have maybe PS4 and PS5. You're used to like using the tooling for PS4, but you're trying to develop on PS5. I think it will be better to use like the PS5 tooling to make those PS5 games, right? Rather than making a PS4 game and then converting it.
How about Xbox?
Oh, I don't know. I'm a PS fan. Yeah, I'm a PS fan.
I'm sure it's not a legal question, but Jazz, what do you do?
Hey, I'm Jazz. I'm a lawyer at Kingwood Mallisons. Thanks for the prompt, for the plug. I'm really interested in this conversation about risk between optimistic and ZK. And I'm just wondering, I guess, I would like to know if this is correct in that where you have that conversation around a transaction taking, let's say, a week to settle on an optimistic roll-up. Say that you do a transaction and it's an invalid state transition and no one's doing a check, no one's submitting fraud proofs, and then you go through like hop protocol or something like that and then jump to a different chain. Does the risk carry to the bridge? And is that something that isn't necessarily present on a ZK system because you can't do invalid state changes in the first place?
What he said. Anyone?
Yeah, I guess I can start that off. So, so you first mentioned, I guess, the hop protocol. So what happens in the optimistic sense is all the activity that happened on the optimistic chain or that state transition there is invalid. So everything that's in, I guess, the remit of the optimistic chain, well, technically that's the only area in which it can interact. So in that sense, whatever's there is the source of truth. But if it's on L1, my understanding is that it wouldn't be able to affect other things because it's, unless, of course, you're looking at, you know, the fraud proof being, or the fraud generation there on L1 as some sort of data for another protocol. But generally, you shouldn't be able to mutate the state of other chains outside of optimism. But yeah.
I thought that if you don't submit a fraud proof, then that becomes the truth. So, yeah, it's the incorrectness kind of just becomes reality, if you put it that way, and whatever consequence that has.
Yeah, I'm just thinking of it from the perspective of, and obviously I'm asking because I want to know like how this actually would practically function, but I'm just thinking that there must be an accounting hole somewhere, right? So would that really be the case that you're effectively draining the bridge of some funds? Because now you're out of the optimistic system, but then there might be a fraudulent transaction that, you know, maybe someone would submit a fraud proof later or something like that, but you can jump out of the chain with hop or a similar bridge in less than a week. So I was just wondering if is that a risk?
ZK loopholes, anyone?
I can't answer the technical question. Do you want to answer that first and I'll jump in with something else?
So you said like if you can move it quickly, if is it a risk or not? Well, it depends on how fast you are, I guess. Like I was contributing to this like project in Harmony before they and yeah, all of my one USDC is like slashed by 80%, like, and that wasn't fast enough. So like, yeah, it depends on how fast you are. But yeah, with the hop protocol, it is pretty fast, isn't it? Yeah.
Can I jump in? And you probably across this, but for others in the room who maybe aren't, I think there's an interesting development in terms of how legal frameworks are trying to grapple with understanding crypto tokens and digital assets more broadly. There's a huge body of work going on, in particular coming out of the Commission, the Law Commission in England and Wales. And one of the things they've been talking about is the fact that in these circles we talk about the single source of truth and the transaction record being proof of ownership. Part of this consultation at the moment is looking at that transaction record being a question of fact, and that is one part of a multi-layered analysis of true legal ownership. So it's a really interesting overlay, well, interesting for the lawyers, maybe the rest of you probably not so interested, so I won't keep going on, but just to point out that these legal frameworks are trying to figure out how to extend their purpose into this digital realm, and there'll be multiple instances of where that happens in both sort of a messy and a clean way, but keep your eyes on what's going on with that consultation in particular in relation to data objects coming out of the UK, because it will be formative here in Australia because we've also got a common law jurisdiction. So happy to chat about that to anyone who's interested. I won't bore the rest of you.
We've got a question from the crowd online. I don't know if you guys knew this, but there was an online crowd as well. So one of our people asks a question to the panel: can we use Cairo to prove data privacy questions from the current use StarkNet uses ZK for scaling, but what is the possibility of building a privacy solution using Stark instead of a snark or a plonk or a halo. Hands up who knows what a plonk is. There we go. There's the 5 people on Earth that know it. Does anyone want to get into that hairy question? Yeah?
Yeah, I can have a crack. So it sounds like it's a data privacy thing. So it's talking about using StarkWare's StarkNet solution for privacy as opposed to scaling, which is, maybe lead to an interesting conversation. But right now, StarkNet is focused on scaling, not privacy. This is where you can explore interesting things where you might have another L3 on top of StarkNet, and that L3 might have off-chain data which is not public and hence private. So there are interesting things you could do where you have data separate and you don't actually reveal the data, but StarkNet, as in its current state, does not hide data. But that's obviously this uses ZKPs, and if that data is not available and is hence hiding essential information about what's happening on an L3, what impacts does that have from a legal perspective? Not, yeah.
That's a big question. Don't know if we've got time for that, but.
To try to answer that question and follow up on what Rez was saying, Circom being the typical ZK snark library for L1 is actually ported to Cairo, and that kind of shows you that there is room for an extra library in order for you to actually create ZKPs that are more kind of focused on privacy. So yeah, it's definitely not there, as in Stark Cairo is on its own is not really there for that level of privacy.
Okay, they left, so they don't care. Okay, 2 questions here. We'll go here first.
Hey guys, I'm Ray. I'm lawyer at Herbert Smith Freehills, same as Susanna. Just a question on the account authorization. I think the interesting thing was the persistent authorization, how it makes it convenient for users that you don't have to pop up every time, so it's convenient for them. But I'm also thinking from like a privacy and like just a contractual perspective. So just first question, is persistence based on time? For example, it's persistent for X hours until after X hours, the pop-up will come up again. Or is persistence based on purpose? For example, once you click OK for one purpose, it will stay like that for that purpose. But as soon as you want to agree to another purpose, the pop-up comes out again. Or is it persistence based on like account, like session login, or just what's the persistence based on? And number 2, like how do you code around that? Because I can see that, because one use case I can see that being is smart legal contracts. So for those that don't know, smart legal contracts basically like a step up of smart contracts, where the smart contract is incorporated within the legal framework and you can use that for business use cases. And I can see the account authorization being quite a convenient mechanism to streamline micro business transactions. But once you get to the big business transactions where you normally want to have parties approving to a certain event, and then maybe like for some oversight, the developer put down a persistent authorization such that the party automatically approves things that normally wouldn't approve. I'm not too sure how practically, like what do you have any mechanisms or controls in mind that in order to prevent that sort of thing happening? Yeah.
As you guys can probably see online, so we'll definitely get the questions answered, but we've got Uri calling in from Israel. Hands up if you know who Uri is. There's a few. He's the CEO of Stark, so he's a good name to know. Uri, if you can hear me online, hello, shalom, and we will get you on very, very soon. So we're just going to figure out how. I probably need your help with the laptop with Chris, so we might just park that. But the cool thing is it's recorded, and so when we do the recordings, which I edit, I'll probably just lump them together as if the question was answered straight away. But if not, then we'll figure it out. And Chris and Arturo are madly rushing to try to figure how to get Uri up online. Hi, Uri. Can you hear us, Uri? Can you wave if you can hear us? There we go. Okay, perfect. We're just going to get your sound sorted so that the audience can hear you. Oh, I think you need to unmute yourself. Surely there's an assistant or Louis. Okay, we're going to get your sound working soon. Chris is on the cards. This is the first time we've done this. Usually we don't have people calling in, so special. Good? There's a bit of an echo, so apologies. Huh? Oh. We need to be. There we go. Okay. Yeah, good. So Uri, can you hear us? Oh, you can't. Oh, now we're muted. Okay. Put it back on, just quickly. Uri, I'm going to type questions to you. So look at the chat.
Can you hear me now? Okay, can you say something?
Sorry, just with the setup that we've got, there's going to be an echo. So we're going to type questions to you in the chat. Okay? Okay.
I mean, with the echo and the screens, I feel like a North Korean dictator. I like the effect. Give me everything. Okay. I've never actually tried being a North Korean dictator. So, hi everyone. First question. Okay, so how I got into Web3. So it goes like this. Most of the people I talk to are about 27 years old, and they've all been mining Bitcoin since the mid 80s. So I don't fall into that category. I came in sort of the fall of 2017. I've been an entrepreneur for over 20 years in optical fibers and medical devices and software and a bunch of different things. But I had this old friend who kept nagging that I should look at the stuff he's been researching as a computer science professor. And I said, Eli, what do you want from me? And he said, let's start a company. And here we are. We've been friends since actually the time most of you have been mining Bitcoin, since the late 80s. So that's that. That's how I came into Web3. I mean, I knew nothing about it. I really knew nothing about it. So I guess this is a bunch of, so I'll repeat the question for the audience. So recent events have led to a lot of soul searching for many projects, as the failure of DeFi protocols, the bear market, and Tornado Cash more recently led to some rethinking of how you do things, etc. The short answer is not really, and I guess there's very sort of different elements bundled here in this. The failure of DeFi protocols, I think more than anything has demonstrated, well, a few things. It's demonstrated that a lot of the tooling is still, painfully absent in terms of tools that allow developers to write secure code and test it properly, etc. There's been a lot of rug pulling, which of course is horrible stuff, and stuff that we shouldn't sort of stand up for in any way. So of course, the law should intervene where necessary, but we as an ecosystem should be, I think, very discerning and very punishing when it comes to interacting with these protocols. The bear market, I think it was pretty apparent that the market was very frothy, and these things, if you've been around the block a few times, you know that these things often end in tears, and so that's the cycle, that's the business cycle. And so that's the bear market. Tornado Cash, Tornado Cash is disturbing in many ways to me as sort of a citizen of the world. The fact that people writing software code which has perfectly, deeply sensible, rightful sort of use cases and are apprehended on the street in the European capital. To me, that's deeply disturbing. And I think it only sort of emphasizes that the infrastructure that we're all building is important infrastructure, and we should keep at it. So that's my personal take on three very different elements.
Sorry, Uri.
No worries.
We'll just have to stick to typing. Was that okay? I'm getting told no. I'm getting told yes. This is definitely not a governance token that's going to go well. So Uri, sorry about the echo, but the question. Okay, I'm going to stand over here. Hopefully this is okay, but the question is, what's the difference between running a business in Web 2 versus Web 3?
So I would actually separate this into two factors. One is sort of running a business in 2022, and in fact running a business post-COVID, and running a Web3 business. So I think these should not be sort of confounded. I think running a business in 2022 means that sort of workforce, software developers, are far more sort of global, and the willingness to even consider sort of remote setups, people are far more open-minded to it. I think COVID has demonstrated that when we're forced to do this, we can actually work rather proactively. To us, it's also demonstrated the extreme benefit of being co-located, not only in terms of productivity, also, I must say, for a lot of the folks here, from an emotional perspective, just coming into the office, seeing other people, engaging the world, I think it's very important for our mental health. And in fact, what we saw during that time was that a lot of people, the work-life balance was lost because of working from home and people sort of forgetting to turn off. So that's sort of the challenges of working, sort of managing a team in 2022, remotely, Zoom, post-COVID, and all that. Web3 presents its own challenges. Unlike Web 2, where it's sort of, generally speaking, as a business, you're interacting with other businesses which are fundamentally a similar creature, meaning they abide by a very similar set of constraints and optimizations. Maybe you're negotiating whatever with an Amazon. It's it's a million times bigger. It's slow moving. It's menacing. It's threatening. It's whatever. But it's two for-profit businesses, legal contracts, and all that. The blockchain space presents all sorts of. I'll give you an example. We are co-funding with the Aave DAO and with the Maker DAO. Projects that are aimed at bringing those two protocols to StarkNet. Now, we're co-funding this. This is a for-profit company, StarkWare, co-funding this effort with two DAOs. Up till that point, I was unaware of any such collaboration. It's a very interesting sort of interaction, right? How do you cut a deal in a world where there's actually no legal contract, where the terms are in fact negotiated in the public arena, for better or worse? What does that yield in terms of an equilibrium? So those challenges are substantial in the Web3 space. What's to me sort of maybe a little older than most folks in this space, what's impressive and often somewhat frustrating is that a lot of insights and wisdom, not only from Web 2, from centuries of human interaction, and sort of the ground sort of this kumbaya of we're starting afresh, people sort of threw out the window a lot of very obvious insights about the way teams and projects and companies should interact, and they're sort of relearning. Reputation matters, and of course reputation matters. It mattered before, it matters still, and those are things that we care for. What am I most excited about when it comes to StarkWare in the coming months? A bunch of things. As you guys may have seen, we put out recursive Starks for general computation a few weeks ago, and this is sort of a necessary component in introducing layer 3 which would be StarkX and custom StarkNets that run on top of the public StarkNet. So that's something that we're very excited about. Bringing public StarkNet to its sort of more scalable, more decentralized, more permissionless phase is what's ahead in the coming quarters. And that's very exciting work. So after that, what do you see as the pathway towards decentralization? So of course, the several components of decentralization. One of them is to allow anyone to run a sequencer and approver on StarkNet. That's very important, and we're working furiously to get there. We then need some coordination mechanism in this network. And we announced the plans for the foundation and the token in this context. And we're working, to bring that out in a healthy and productive manner that allows developers to focus on building and fosters the strong developer ecosystem around StarkNet. I think we're seeing very promising sort of early indications that this is what's emerging, but there's a lot of work ahead. And if you get time, please explain the drawings behind you. Okay, so this is actually a very interesting point. Hi, Tim. I see, it's funny to see someone I know on the other side of the planet. So I'll say this. We're not as good here at, I was pointing this out earlier, we're not as good with contraceptives as we are with software. This is Bring Your Kids to the Office Day. The school year starts in a couple of days. There are like 50 kids here. I brought my youngest, and the art is his. I'm auctioning this off. If you're interested, DM me. Send me tokens, many tokens. And that's it. Does that explain the drawings behind?
Where's the camera? Can you see? Oh, yeah, good. Oh, sorry about the echo. Nathan's put his thumb. Okay, so just while I'm talking, my sound guy says that you can't talk at the moment. We haven't figured out this technology. I think Web3 can really. We don't have the power to do this, but we really appreciate with the 50 kids in the room. It was really quiet on your side, so I don't know how you've done it. Very good soundproofing. So thank you very much for your time. And the audience here wants. You can probably hear the clap, the round of applause. But if you guys. We absolutely love StarkNet, and we're definitely going to do more of these, and hopefully have you guys and you tell your friends. Just bring one other friend, that's it. If it's standing room only, people can hear us out the back. Even if it's piling onto the street, we're going to do more for StarkNet. So thank you very much, Uri.
Thank you, everyone. And we love having you in this emerging ecosystem. And I hope to see you soon face-to-face.
Fantastic. Oh, but yeah, there we go. Okay, thank you very much. Cheers. And the audience, thank you very much, everyone, for doing, taking the time out of your evenings to come here for this, even though it was a bit haphazard doing all this kind of stuff. If you want to follow along, if we go to the next slide, Chris, if we can do that, is there a way? Hang on, there we go. So clicky, okay, go back just one more. So we've got a few upcoming events. Hands up who knows about OzCryptoCon. Hands up who's going to OzCryptoCon. Hands up who wants to go to OzCryptoCon and doesn't have tickets yet. And if you want tickets, yeah, oh here, right, okay, cool. I never see anything behind me, so that's too bad. But I can sort you out with tickets, so come see me after this. I'll probably be running around cleaning up. If you help me clean up, I will probably, be more inclined to get you sorted for a ticket. It is that easy. Pick up a bit of litter. It's great. Chris, did you have... I know, and that's the thing. We've got another event tomorrow. So the Oz DeFi Association, we are always on the last Wednesday of the month. So if you're in town, Chris, all good? Oh, I was out of the Oh, that's the line. Okay, so swim between the flags. I apologise. But we do that the last Wednesday of every month. There's other groups around Sydney, around Melbourne, Brisbane. Perth is doing a lot of stuff. Adelaide, we had our first event in Adelaide. It was just a networking event with 10 people. We had 15 invited. 67% turnout rate is not bad. So Adelaideans are doing their thing. And then on Mondays, we do Twitter Spaces. I didn't do one yesterday because it was my birthday and I was getting drunk. Apart from that, we always do Twitter Spaces on Mondays, and he will drop some knowledge bombs and some swearing and stuff like that. So it's a good thing I record it. And I don't know if you guys knew this, but Twitter Spaces delete stuff after 30 days. But we've been downloading it, so even the past ones we will be keeping and putting out somewhere like Spotify, and then probably getting banned because we're talking about crypto. But who knows? It's the whole centralized censorship kind of debate, but we'll see for now. Next slide, please. Thank you. Other announcements? Do we have? Keep going. The links. Yeah. So if you can tell them about the how, what they can do to learn.
So this is what I did to actually earn this T-shirt back at the event. What you have to do is download ArgentX, which is a Chrome-based wallet for StarkNet. And then if you go to the GitHub link, you will see a tutorial where you have to interact with contracts on the Explorer, which is called Voyager. And then you can have worthless ERC20 tokens, which you need to show us tomorrow, and you will get your StarkNet T-shirts.
Or tomorrow, or when you can and stuff. We've got a few T-shirts and stuff. So we've got, it's not these T-shirts, it's grey. I'll send a photo around. Just by the way, these slides, apart from this being recorded and apart from it going on our YouTube and stuff like that, we are going to share these slides. I'll make sure the guys are okay with sharing it. So with the links and all that kind of stuff, if you didn't take the photo and stuff, yeah, all good.
Yeah, just final one from me as well. Immutable is hiring, so if you are interested in hard problems, come talk to myself or Miranda at the back. She's giving a wave. Or visit immutable.com. But yeah, we're solving hard problems in the StarkNet space, and if you're interested, come talk to us.
Fantastic, and we'll go to the next slide. I don't know if there is one after this. Obligatory QR code, StarkWare. Hopefully you've seen the website, NotCentralised, which is, oh, thank you, and yes, I've got the clicker. So usually after these, if this is your first event with us, there is a hotel called Republic. There's a rooftop, so it's just on the corner of Pitt and, is it Bridge? Pitt and Bridge. So hang around here, we'll clean up a bit, we'll all head up there, or some of you can head up there early and get to the top of the rooftop. There is more food that we can order and stuff there, so hopefully you guys can make it if you are all thinking about sticking around. And next slide, I think, click it, oh yeah, that's right. I'm not used to having something in my other hand. Thank you. Thanks everyone. And thank our audience, thank our panelists as well, who flew in from Brisbane. And I asked, who flew in? And I'm looking here, I'm not looking back there. So thank you for flying in from Brisbane. That was amazing. And thank you for walking over from Immutable. And
7 minutes.
7-minute walk, guys. It's not too shabby. And so, look, if you want to talk to anyone here, please do. And stick around, hang around. There's still some more drinks there and stuff. And if you can take your drinks with you, your rubbish, there is a garbage bag next to the bins I've just put out there, and just chuck it in and get more drinks. And we'll stick around for a bit until we all walk out. Okay, cheers, guys.